Good morning. Today again we are here for the continuation of the last class. Last class we are talking about the pH calculations. We have done pH calculation for the mixture of strong acid, for the mixture of strong base, mixture of strong acid and strong base, and we have done the pH calculation for the mixture of strong acid and weak base. Now we have two things more. One is the pH calculation for the weak acid strong base. Last one is the pH calculation for the weak acid and weak base. First let me start with the pH calculation for the weak acid and the strong base. For example, weak acid and strong base. pH calculation for the mixture of weak acid and strong base. We know acid and base will react and form the salt plus water. This is the neutralization reaction. Now here I can take the acid, weak acid, for example acetic acid. Strong base I can consider as sodium hydroxide. What will be the product? What will be the product? It will be the sodium acetate plus water. This is the salt. This is the weak acid, this is the strong base, that is the salt. Now here also we will have three different situations in terms of milli equivalent. We have three different situations. First situation we can have case 1. Case 1, milli equivalent of acid may be same as milli equivalent of base. It is equal to base. Suppose the milli equivalent of this is N1V1, milli equivalent of the base is N2V2. The first case means N1V1 equal to N2V2. That means after the reactions, no acid, no base will left in the reactant side. All will get completely converted to the product side. I mean, it will give the salt and water. Therefore, this after the formation of the salt, what the salt will form? Salt will form your sodium acetate. And this sodium acetate in water, obviously we know all salts are decomposed in aqueous solutions into their corresponding ions. Here also no exceptions, it will decompose into its corresponding ions. Now this acetate part, which is the part of the weak acid, this acetate part can react with the water and form acetic acid plus OH minus ion. This acetate ions react with water, form a new compound, acetic acid. That is called your salt hydrolysis. What hydrolysis here? This anions are undergoing hydrolysis, therefore it is called anionic hydrolysis. For anionic hydrolysis, due to the anionic hydrolysis, what is produced? OH minus ion is produced. That means the solution will be basic. In the pH for this solution is nothing but your pK, nothing but pH equal to 7 plus half pKa plus log C. The solution will be basic. As the solution will be basic, the pH will be greater than 7. pH equal to 7 plus half pK plus log C. What is pK? It is the pK value for the weak acid. Here weak acid is the acetic acid. And what is the C? C is the salt concentration. How to calculate the salt concentration? The C will be nothing but milli equivalent of acid or milli equivalent of the base, because in this case milli equivalent of acid and base, both of them are same, divided by total volume V1 plus V2. This will give us C, and pKv value will be given, or otherwise K value will be given. From the K value we can calculate the pK. We know pKa is equal to minus log of Ka. Either K will be given or pK direct will be given. By putting these values, we can calculate the pH, and pH will be greater than 7. Solution is basic. Anionic hydrolysis produces anions. Anions means O is minus. Solution will be your basic solution. This is how we can calculate the pH for a mixture of weak acid and strong base. When milli equivalent of acid and base are same, and that case is called anionic salt hydrolysis. The salt undergoes reaction with the water, produces a new compound acetic acid and produces OH minus. That is called anionic salt hydrolysis. Solution is basic. Resulting solution is basic. pH is more than 7. pH is equal to 7 plus half pK plus log C. This formula is important. We can derive that, but I am not going to derive now because we do not have much time to derive in the exam halls and go for the solutions. Therefore, the formulas we should keep in mind. Otherwise, it will take no time to derive formula, then go for the solving problem. That is not possible in exam hall. C is salt concentration. As the milli equivalent of the acid and base, both of them are same. The milli equivalent of salt divided by total volume is the salt concentration, that is C. And K value will be given, or direct pK will be given. From that we can calculate the pH. What's about the case 2? We can have a case 2. Case 2, we can have milli equivalent of the weak acid. Milli equivalent of the weak acid N1V1, milli equivalent of the weak acid N1V1, milli equivalent of the weak acid may be greater than milli equivalent of the strong base N2V2. In that case, what will happen? In that case, what will happen? First of all, you should write the reaction and check. This is the acid, acetic acid plus sodium hydroxide gives sodium acetate plus water. Here the milli equivalent is N1V1, here N2V2. Initially it is 0, 0. At the starting, milli equivalent of this N1V1, this is N2V2, and these are 0, 0. Now this milli equivalent is excess. This is excess reagent, this is the limiting reagent. As the milli equivalent of this base is less than the acid, that's why this base will act as the limiting reagent, and this is the excess reagent. Therefore, after reaction, milli equivalent of acid left will be N1V1 minus N2V2. This will become 0 and this will become N2V2. That means after reaction, what we are having? We are having weak acid and the salt of the weak acid with a strong base. That mixture is called your acidic buffer solution. Weak acid, after reaction, what is left? Weak acid and salt of the weak acid with the strong base. That kind of combination is called your acidic buffer. And for acidic buffer, the formula to calculate the pH is nothing but pH equal to pKa plus log of salt by acid concentration. This equation is also known as Henderson equation. This equation is also known as Henderson equation. What is the salt concentration? Milli equivalent of the salt by total volume. What is the acid concentration? The milli equivalent of the acid left after the reaction divided by total volume. And pK value will be given. Thus we can calculate the pH. Salt concentration is N2V2 by V1 plus V2. And acid concentration is acid milli equivalent of the acid left after the reaction. What is that? N1V1 minus N2V2 by total volume. Now let me write here the salt concentration. Here the salt concentration is nothing but N2V2 by V1 plus V2. And acid concentration here is nothing but N1V1 minus N2V2 by V1 plus V2. By putting the values, we can calculate the pH. This is called your acidic buffer. This is called your Henderson equation. Clear? Sure. One more case is left. Case third. What is the case? Can you guess? Case third is this. Third case is this. Milli equivalent of the strong base is greater than the milli equivalent of the weak acid. In that case, the resulting solution will be your basic, because the strong part is in excess. Therefore, this will decide the nature of the solution. Therefore, in the third case, what will happen? Third case, it is very simple. When the milli equivalent of the strong part is higher than the weak part, the resulting solution will be your basic. As the resulting solution will be basic, therefore here simple, OH minus ion concentration will be equal to N2 V2 minus N1 V1 by V1 plus V2. Thus we will get the OH minus concentration. Once we get the OH minus concentration, we can calculate the H plus concentration. How? We know H plus into OH minus is equal to Kw. This Kw is called ionic product of water, which is 10 to the power minus 14 at 25 degrees Celsius temperature. You know it? Yes? Yes. Therefore, from here I can calculate H plus concentration. H plus concentration will be your Kw by OH minus concentration. Therefore, this will become 10 to the power minus 14 divided by OH minus concentration. This OH minus concentration will go from here. Put the values of the OH minus concentration, calculate the H plus concentration. Once H plus is known, they are very simple to calculate the pH. pH is nothing but minus log of H plus concentration. This is how we can calculate the pH of a mixture of weak acid and strong base when the milli equivalent of the strong base is higher than the milli equivalent of the weak acid. Clear? Sure? I can solve a problem. I can take an example and solve it. Let us see. Suppose initial case. Suppose case 1. Case 1 means milli equivalent of the acid and milli equivalent of base are same. Suppose let me take the acetic acid and base is sodium hydroxide. Therefore, it will become sodium acetate plus what? I am taking a case where the milli equivalent of the acid and base, both of them are same. For example, this is suppose 500 ml, 0.1 normality. This is also 500 ml, 0.1 normality. Initially, this will become 0. Therefore, at the starting, milli equivalent of acid will be your 50. Milli equivalent of the base will be 50. Starting it will be 0. After the reaction, what will happen? This will become 0, this will become 0, this will become 50. That is, milli equivalent of the salt is 50. Therefore, this is a case of salt hydrolysis. What kind of hydrolysis? Anionic hydrolysis. And we know anionic hydrolysis produces anions, OH minus ions. That means solution will be basic. Therefore, pH will be higher, greater than 7. Therefore, the formula is pH equal to 7 plus half pKa plus log C. C means milli equivalent of the salt by the total volume. Therefore, here C will be milli equivalent of the salt 50 by total volume, 500 plus 500. That is nothing but 50 by 1000. This is nothing but your 5 into 10 to the power minus 2. 5 into 10 to the power minus 2. That is C. And pKa value will be given. Let us consider the pKa value for the acetic acid is 4.7. This value will be given. I am considering the pKa value of the acetic acid. Acetic acid is 4.7. Therefore, by putting the values, what I will get? I will get pH equal to 7 plus half 4.7 plus log of 5 into 10 to the power minus 2. Solve it, you will get the pH. Very simple. Only you need to keep in mind, when the milli equivalent of the acid and base are same and one of the component is weak, in that case it goes for the salt hydrolysis. This case it is the anionic hydrolysis. Anionic hydrolysis produces anions, OH minus ions. Solution is basic. Therefore, pH is 7 plus half pK plus log C. This pKa value for what? Weak acid, A4 acid. Okay. Similarly, if you take the milliequivalent of acid part is higher than the base part. Suppose this you take 0.2. In this case, the milliequivalent of this will be your 100. Milliequivalent will be 100. This will be your 50. This will be 50. Therefore, after reaction, what will happen? This acting as a limiting reagent, this acting as excess reagent. Therefore, after reaction, it will remain 50. It will become 0. It will become 50. That means we are having weak acid and the salt of the weak acid is strong base. There is a case of acidic buffer. Am I right? Yes. Acidic buffer. And you know, for acidic buffer, Henderson equation is P is equal to pKa plus log of salt by acid concentration. Can you tell me what is the salt concentration, acid concentration here? Concentration means milliequivalent by total volume. Here also milliequivalent is 50. Total volume will be how much? 500 plus 500,000. Here also milliequivalent of the acid is 50 divided by 1000. That means these two things are same. Therefore, this will pKa plus both of them are same. It will be 0. Therefore, here answer will be 4.7. Acidic buffer. Yes. If you take the reverse case, this is 0.1, other is 0.2. But the milliequivalent of the strong base is higher than the milliequivalent of the weak acid. The reverse case. Then what will happen? This will become your 50. This will become your 50. This will become your 100. After reaction, this will become your 0, but this will remain 50. This will remain 50. In that case, as the strong part is higher in milliequivalent than the weak part, and strong part is base, therefore resulting solution will be your basic. Therefore, here the OH minus ions concentration is the milliequivalent of the base, that is 100 minus milliequivalent of the acid, that is 50 divided by total volume. Total volume will be your 500 plus 500. That should be your 50 by 1000. This will be nothing but your 5 into 10 to the power minus 2. As OH concentration is known to us, we can calculate the H plus concentration. The H plus concentration is nothing but Kw by OH minus concentration. Kw is nothing but 10 to the power minus 14. OH minus concentration, we have got here 5 into 10 to the power minus 2. Therefore, it will become 0.2 into 10 to the power minus 12, I suppose. Am I right? 10 to the power minus 12. Am I right? Sure? Okay. Therefore, this I can say 2 into 10 to the power minus 13. H plus concentration. Therefore, I can calculate the pH. Simple. pH is nothing but minus log of H plus and concentration. That is nothing but minus log of 2 into 10 to the power minus 13. Therefore, how much we will get? 13 minus log 2. What is the value of log 2? 0.3010. Put the value, do the calculation. This is how we can calculate the pH of a mixture of weak acid and strong base. Okay, thank you.